Hello and welcome back to the tutorial series where we communicate between a Pico and Pico W using Bluetooth Low Energy. In this part we will use a potentiometer to print its values via console and then control the brightness of an LED connected to a Pi. Let's get started. Alright, first let's discuss the wiring diagram, which I have here. Here's the Pico and here's the Pi. You don't have to use a Pi 4, you can use any Pi that has Bluetooth, like the Pi 5, the Picozero W2, any Pi. You can also use the Pico W2 if you wish. Let's start first with the LEDs here. Now this LED is from the last part. This is just indicating when the Pi is connected to the Pico, it's connected straight to pin 17. This next one is connected to pin 27. And here's the common ground. Here's a potentiometer. The middle pin will connect to ADC0 or GP26. It is one of three analog pins on the Pico. Then we have 3.3 volts, which is the fifth pin here. So let me get right here, and it connects to this leg, and this leg connects to ground. Let's move on to the code. First on Picozero, first I need to address something I didn't mention, is that you can install Picozero not using the interpreter and also not using Pi because it didn't work. You have to use manual install. As you can see in the instructions, it tells you to use the big GitHub repository. Now, the Picozero.py file doesn't work. It has a 404 error. So just clone the repository, then follow the instructions here by making the files section open. Then go to wherever you downloaded Picozero and then upload to your Pico, and then run this code as a quick test. And if it works, then you're ready to go. And in this case, I've already done that. Yes, I have a lot of code here, but here is Picozero. Just to show you, this is Picozero, so I managed to get it to work. Anyways, let's talk about the code. First in the Pico. So I've shown this code before, but I'll show it again. So we import our libraries. We have pot as 26, which is our potentiometer. We have the LED for blinking when we're connected to the Pi. Then we have the parameters for BLE. This is just to print the MAC address. Then we set our UUIDs like always. We have our other parameters, including for Bluetooth. Message count I kept there because I was testing this code. You really don't need this at all. In fact, you can just delete it. So then, of course, we have our encode and decode message as usual. Then, of course, we have our LED task just like before. And then here we have our message, which is pot.value. And then we send the message here, and we let it sleep every 0.1 seconds. And then we have our exception statement right here. And then we have our run peripheral mode. So again, I've shown this code before, so make sure you run in peripheral mode. And of course we have our tasks here. Make sure you include the blink LED task. And that's it for this code. Now let's talk about the code on the Pi. So I have my Pi 4 on. Let's start with PWM value. So we have the usual libraries. We have pin 17 for our LED, the Pico address. Make sure you update this to whatever yours is. We use the UUIDs from the Pico to connect, as always. The only thing that matters really here is that we read from the Pico. Essentially, we read from the data it's sending us from the potentiometer. Here I put potentiometer value, and then we read the response from there, and we wait every 0.1 seconds just to synchronize with the Pico. We have our exception statement here. We have our blink task, and we of course connect. And then unlike the Pico, we have to do the get event loop, and we have to use the run until complete, and make sure to include Pico address. That's just for regular PWM. For LED, we simply just include PWM LED. I called it green, and then right here we put green.value, which is the float of the response. So again, we have to convert this to float in order for it to work, and everything else is still the same. So that will be it for our code, and this will be our main setup. So that's really it for the setup. So in the next section, we will run the demo for both the potentiometer and then the LED. So let's just get started. Hey guys, so let's begin. Now, I ran this already, but let's do it again. So I will run this code here first. Okay, so now I'm going to run this again. I'm gonna wait for it. Okay, so we move this a little bit. You can see the values update, and you can see I take it all the way to 1, and there you go. Now let's take it back to 0, and you can see the values update every 0.1 seconds. And there we go. So that's it for this demo. So let's exit out of here. And I'm also going to exit out of here. And that's it. In the next demo, we're going to add an LED. So let's move on to that. Hey guys, so here is the live demo. I have the LED blink. So let me show you these so you can see. Look how the LED is blinking. And note the LED is connected to the Pi. And look how it goes. And you can see that the value is now 1. So let's turn it back down to 0. And now the value is down to 0. So that's it for this demo. So that's it for this demo, guys, and also that's it for this part of the tutorial. However, we are not done, as we have one last part of the series. Yes, I decided to make it 5 parts rather than make it 10 parts. And that's because I wanted to focus on the basics. So in the next part, we will use buttons to both blink an LED and also print messages to the console. And before I end this video, I should note that these can be used for anything else. For example, the potentiometer tutorial here can be used to control the direction of a servo, and can be used for anything that requires analog control. So that's it for this video, guys, and I'll see you next time.